Hello students, I am Nilanjana Sanyal. Welcome you all to my channel Learners Online Math Classes. Our today's topic is the multiplication law of logarithms. Just like you have some laws on exponents and indices, you have some laws on logarithms as well. We have learnt about some restrictions on logarithms. We have learnt about the 4 properties of logarithms in our previous session. And today we will be learning about the multiplication law of logarithms. And e is greater than 0, a is not equal to 1, x is greater than 0, and y is greater than 0. And you will be knowing what do they represent very soon. Okay? So without any further delay, let us start with our today's session. Let us know about the multiplication law of logarithms. It is log of x times y to the base a is equal to log of x to the base a plus log of y to the base a. Now you see the base is a, therefore a should be greater than 0 and a cannot be equal to 1. We have seen this restriction for the base of any log term. And x should be greater than 0, that means x should be a positive number and y should be a positive number. Because we know that the argument of a log term cannot be negative or cannot be equal to 0. So x times y, you may say that if x is a negative number and if y is also another negative number, then even then the product will be a positive number. If you multiply two negative numbers, you get a positive product, definitely. But what happens to these two terms? If x is a negative number, you cannot have a negative number as the argument for any log term. So even if you take x as a negative number and y as a negative number, the left hand side will be a valid log term but not the right hand side terms. Okay, so x should be a positive number and y should be a positive number. Now let us come to the proving of this rule. Okay, so we start from the left hand side, log of x times y to the base a. This can be written as log to the base a and xy. This is the third property of the third or fourth property, I really do not remember exactly, that we have learnt in our last session. X can be written as a to the power of log of x to the base a, and y can be written as a to the power of log of y to the base a, and these two are multiplied together. Okay, that is why I had said in our previous session that all the 4 properties that we have learnt or we are learning are very important and we often use them in order to solve questions related to logarithms. Okay, so x can be written as a to the power of log of x to the base a times y is written as a to the power of log of y to the base a. And since this is a to the power of, I can take this as m times a to the power of n, we will be applying the law of indices and we can write this to be as a to the power of m plus n, that is a to the power of log x to the base a plus log of y to the base a. And again we are using another property of logarithms that we have learnt in our last session as well. That is, if you have log of e to some raised to some power to the base a, that will be equal to the power. So this is equal to the power, or this is equal to log of x to the base a plus log of y to the base a, which is the right hand side. So we have proved the multiplication law of logarithms, and we can, instead of taking this on the left side, we can take this on the left side as well. I have just rewritten this rule or law. This time it is log of x to the base a plus log of y to the base a equal to log of x times y to the base a, because you need both the versions. Okay, you may have to combine two terms to make a single term containing log, single log term, or you may have to break one single log term into two log terms. Okay, both are needed. So what is the proof for this part? Let log of x to the base a be p, and so converting it to an exponential equation, it is base raised to the power of this p, that is e to the power of p equal to x. And let log of x to the base e is equal to q. So again converting it to an exponential equation, it is e to the power of q equal to y. Okay. And then this is the left hand side, log of x to the base e plus log of y to the base e. So this is equal to obviously p plus q. Okay, so the left hand side is p plus q. And now we are taking e raised to the power of log of x to the base a plus log of y to the base e. And this is equal to p plus q. So this is equal to e to the power of p plus q, which we can separate using the law of indices. This is equal to e to the power of p times e to the power of q. And what is e to the power of p? It is x. And what is e to the power of q? It is y. So this is equal to x times y. Okay. And what do we do next? We take the log of both the sides. We have taken the log of the left side. This is the log of the left side. This is the left side and this is the right hand side. So we are taking the log to the base a of both the sides. So it is log of e raised to this power to the base a equal to log of xy to the base a. Okay. And again using the property of one of the properties of logarithm, this is equal to, we have used the same property over here, log of e raised to some power to the base a is equal to that power. So this is log of x to the base a plus log of y to the base a equal to log of x times y to the base a. Okay. So we have proved both the versions of this multiplication law of logarithms. Now let us look at one of the example questions. Okay. We will be doing many more questions related to logarithms. Don't have to worry. This is just a simple one, but it uses this law. Write log of 2 to the base 3 plus log of 5 to the base 3 as a single logarithm. So we will be using this form. Okay. So we are given two terms having the same base. This is important. The base should be the same. If you have two terms with the same base connected by the plus sign, the arguments get multiplied. So this will be equal to log of the two arguments are 2 and 5. So they are getting multiplied. 2 times 5, the base remains the same. So it is log of 2 times 5 to the base 3, or this is equal to log of 10 to the base 3. This is the single logarithm term which is equivalent to these two logarithmic terms added together. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.